Good day, students. Welcome to Mathgotserved.com. And this clip, we're going to be going over section 2.3 of our geometry virtual text, focusing on how to calculate the distance between 2 points. Don't forget, we have 5 practice problems at the end of this presentation that we'd like you to try out in order to demonstrate mastery of the contents of this tutorial. Alright, to get us started, we're going to take a look at the formula that's going to guide our problem solving process. So the formula that we're looking at right now is the distance formula. Alright, so the distance formula is as follows. The distance between 2 points. Let's say the 2 points are given by x1, y1, x1, y1, and x2, y2. We're following the same naming convention that we use in the tutorial before this, where we're looking for the midpoint. So the first point will be x1, y1, and the second point x2, y2. The index basically indicates the order of the points. All right. So we have 2 points x1, y1 and x2, y2. So the distance between them, we're talking about the straight line distance, of course, is given by the square root of x2, let's write that down again, x2 minus x1 square plus the quantity y2 minus y1 square. All right, so the square root of that. So this basically is your distance formula. Now, if you take a look at this formula, you'll notice that there are some components here that you've seen before. For example, x2 minus x1 is the run in your slope formula, and y2 minus y1 is the rise in your slope formula. So basically the distance between 2 points is the square root of the sum of the square of the rise and the run. All right, so they're all related to each other, but this is just I'm just highlighting that point for you. Now let's take a look at the steps that we're going to be using to guide our problem solving process so that we do not make mistakes in the whole process. So first things first, you want to go ahead and label the points that you're given. All right, so you want to know which one is the x1, y1 and x2, y2. After you're done labeling your points, you go ahead and write down the formula. You want to know exactly what goes where. So write down the formula, and then when you're done writing down the formula, we're going to proceed to substitute what you labeled in 1 into 2. So substitute and simplify. All right, you're going to simplify the resulting expression using the order of operations. Please excuse my dear Aunt Sally. All righty. Okay, so let's go ahead and take a look at 3 examples and give you an opportunity to practice on 5. All right, so the instructions for the examples that we're going to be working on are as follows. We are to find the distance between the given points. Okay, find the distance between the given points. All right, so for question 1, let's say we have the pair of points 4, -1, and 4, 3. All right, so let's go ahead and find the distance between these 2 points right here. We're going to make use of the distance formula. Now, there are different ways to find the distance between 2 points. Now, if with a certain kind of configuration, it will be quicker sometimes to just sketch the graph of the points, and then you can easily determine what the distance is. But in other cases, it's not that easy. All right, so the first step we're going to employ is to label the points. Okay, so call this x1, y1, and then call this x2, y2. Now let's go ahead and write down what the formula is. So the distance formula D is going to be equal to the square root of x2 minus x1 square plus y2 minus y1 square. All right, so you might wonder, when is it quicker to generate the distance between 2 points by just graphing? Now, in a scenario like this, if you notice, the x-coordinates are identical, okay? So if the x-coordinates are identical or the y-coordinates are identical, you have either a vertical or horizontal line. In this particular case, the x-coordinates are identical, so you have a vertical line. If you graph it, all you're just looking for is the rise, all right? So the distance from -1 to 3 is 4 units, so the answer is 4. Alrighty, so just taking a look at the points, if you have a scenario where the x's are identical or the y's are identical, graphing will be an optimal route to take there. So let's just use the formula just to show you that the correct answer is going to be 4. Remember, the focus of this presentation is how to use the distance formula. Okay, so label your points, write down the formula, substitute. So distance d is going to be the square root of x2, which is 4 minus x1, 4, square, plus y2, 3 minus y1. You notice y1 is negative, so when substituting negative values, you want to use parentheses to avoid making sign errors. All right, so you square root that, and then that's going to give us the square root of, now you notice 4 minus 4 is 0, 0 squared. Remember, we have a vertical line, so we're not surprised that the run is 0 because there's no displacement in the horizontal direction. Plus 3, now we have to, remember we're using PEMDAS to simplify, okay? So in PEMDAS, you do your parentheses first. So the operation in the parentheses, we have minus on minus. Anytime you multiply in the same signs, you always end up with a plus, plus 1 square. Okay, so let's finish dealing with that minus with the operation in the parentheses, and then we'll focus on the next step in PEMDAS, which is exponentiation. 0 square is just 0, plus 3 plus 1 is 4, 4 square. So we're done simplifying the operation in the parentheses, so we can now square that second number. So our distance is going to be 0 plus 16, which is the 16. The square root of 16 is equal to 4. All right, so ladies and gentlemen, the answer to question number 1, the distance between those 2 points, is 4 units. Alrighty, let's take a look at question number 2. So in question 2, let's say we have the pair of points, -4, -8, and -3, -3. Okay, so we're gonna go ahead and follow the same procedure that we applied in question number 1 to find the distance between these 2 points. Okay, so the first thing we're going to do is we are going to go ahead and label the points so we know what goes where. So this is x1, y1 for the first point, x and y coordinates, and then x2, y2 for the second point, the coordinates. And then next step is to write down the distance formula. Alrighty, so the distance formula is the square root of your run square, x2 minus x1 square, plus your rise square, y2 minus y1 square. Of course, you square root the sum of the squares. Now, step number 3, we're going to substitute what we know into the formula. So we have the square root of x2. Now we have a lot of minuses we're substituting here, so let's do this. x2 is -3 minus x1, which is -4. Close that, quantity and squared, that's your run, plus y2 minus y1, that's your rise, so both of them squared, and then you're taking the square root of the entire thing. Alrighty, Okay, so now that we're done substituting, the final step is to simplify using our order of operations. Okay, so please excuse my dear Aunt Sally, we're going to look into the parentheses and do the operation first, and then exponent, and then add and subtract. Alrighty, so let's do it. Negative 3 minus minus, we have two minuses there, so that will give us plus. Remember, anytime you multiply the same sign, you end up with a positive. And then we have negative 3 minus minus here makes that a plus, plus 8. Square that. Okay. Still working with the parentheses. Let's do the operation in the parentheses. So for our run, negative 3 plus 4. Signs are different. Subtract and keep the sign of the bigger. So it's going to be positive 1 square plus negative 3 plus 8. Subtract and keep the sign of the bigger, which is 5 square. Alrighty, so simplify further. Now in the order of operations, we are dealing with exponents. 1 square is 1 times 1, which is 1. 5 square is 25. And ladies and gentlemen, the distance between the 2 points is given by the square root of 26. Now, before we wrap this up, let's check to make sure that this cannot be simplified any further, all right? So we'll take 26 and decompose it to see if there are any factors that repeat. So I'm going to look at a prime factor decomposition. Take out 2. 2 goes into 36, 26, 13 times. So there are no perfect squares that are a factor of 26. What does that mean? It means that root 26 is irreducible, so this is the final answer. Okay, all right, let's take a look at one more example and then give you an opportunity to do some practice. All right, for number 3, let's say we have the pair of points, negative 2, 2, and negative 4, negative 4. So the task here is to find the distance between these 2 points. Okay, all right, so we're going to be following the same procedure that we used for problems number 1 and 2. Remember what the first step is. What is the first step? The first step is you label your points, x1, y1 for the first point, and then x2, y2 for the second point. Okay, so now we're going to proceed to step number 2. Step 2 is to find the distance formula. So let's go ahead and write down the distance formula. So that's x2 minus x1 square, that's your run square, plus y2 minus y1 square. Don't forget, if you want to gain access to all the formulas that you need to know for geometry, visit our website at mathgotserved.com. You can gain free access to that and other important vocabulary terminology that you need to know for the course. Okay, so step number 3, we're going to substitute and solve. So the distance between the 2 points is going to be, now let's look at my x2s. So y2, let's look at the x's. Oh, they're both negative. All right, so x2 is negative 4 minus x1 is negative, so I have to put it in a parenthesis. Very, very important. Whenever you're substituting negative values for a variable, you want to use parentheses to avoid making sign errors. Plus, y2 is negative 4 minus y1 square. Okay, so after you substitute, we're now going to simplify using the order of operations. Please excuse my dear Aunt Sally. So the distance is going to be the square root. Now focus on the operation in the parentheses. Here we have negative 4. Minus times minus is a plus. Plus 2. Square that. Plus, here negative 4 minus 2, the signs are the same, so you add and keep the sign. Minus 6 square. And then now let's simplify further. For the first one, we still have a parenthesis operation that needs to be executed. So negative 4 plus 2 is negative 2. Quantity square. And then here we just have to proceed with the exponential operation. So we're going to exponentiate Negative 6, raise it to the second power. Negative 6 times negative 6 is 36. Remember, when you raise a negative number to an even power, the sign becomes positive. Okay? All right, negative 2 squared again is negative 2 times negative 2. We're raising a negative number to the second power, so it's going to be 4, positive 4, plus 36. Okay, moving right along, let me split up my workspace and continue my work right here on the right side. All right, so what is 4 plus 36? 4 plus 36 is 40, so d is equal to the square root of 40. Are we done? Well, we have to make sure to see if we can simplify this, okay? So how do we know if we can simplify this? Well, we'll ask ourselves, is there a perfect square that's a factor of 40? Some of us can do this mentally. 4 is a perfect square and is a factor of 40, so this is root 4 times 10. And then if you root 4, you get 2, and your answer is going to be 2 root 10. Okay, so that's how you do it mentally. But if you want to work it out, let's show the steps. We'll take 40 and we decompose it completely, looking for repetition in factors. Take out the first prime factor, which is 2. 2 goes into 40 20 times. So we want to reduce this, okay? 2 goes into 20 since it's even 10 times. 2 goes into 10 since it's even 5 times. Now, do you notice repetition with the factors? Absolutely. 2 times 2 is a perfect square, which is 4. So what is the square root of 2 times 2? If you root that, it's going to come out as a 2, okay? And then these two numbers right here, 5 and 2, they do not have partners to break out with, okay? So 2 and 5 are not perfect squares, so they're going to stay behind. So if we reduce root 40, it's going to be, see this 2 times 2, when it comes out as a 2 because the square root of 2 times 2, or the square root of 4, is 2. And then this 2 and 5 stay behind. We just multiply them together to get 10. So the simplified form of root 40 is 2 root 10. Okay, so that's the answer to question number 3, the distance between these 2 points. Now it's your turn to do some practice problems. All right, now it's your turn to carry out some practice problems. We have 5 practice problems for you to try out. So go ahead and pause this video presentation at this time and work on these problems. When you're done, click on the playback button and we're going to reveal what the correct answers are. Alrighty, welcome back. So hopefully you had a chance to try the problems. The answers are as follows. Number 1, the answer is 13. That's the distance between the 2 points. For number 2, the answer, this is number 2 right here. For number 2, the answer is square root of 2. For number 3, the distance between the 2 points is 9 root 2. For number 4, the distance between these 2 points is root 17. And for number 5, the distance between the 2 points is 2 root 26. All right, so how well did you do in these 5 practice problems? Let's know in the comment section below what your score is. And if there are any questions or clarifications that you want in these 5 problems or what we did in the tutorial, let us know in the comment section and we'll be more than glad to support you. Thanks so much for taking the time to watch this presentation. Really appreciate it. If you found the contents of this tutorial helpful in your studies of the distance formula, do give us a thumbs up. Your positive feedback is extremely valuable to us. Don't forget to subscribe to our channel for updates to other tutorials such as this. Tons of support resources can be found at mathgotserved.com/geometry. Do check it out. Thanks again for watching and have a wonderful day. Goodbye.